Welcome everyone to another Automotive Talks episode where we interview the most emblematic people and leaders of the industry. Today we have the privilege to talk with Nan Kochar, VP of Automotive and Transportation at Siemens. Nan, how are you?
I'm good, thank you.
I would like to start with a general question of what's the role of technology playing in the development of the automotive industry?
Well, as you know, the automotive industry has been going through major transformation, and technology plays a major role in handling that transformation, not only from a technology perspective, but also delivering the business transformation for the automotive and transportation industry. There are obviously several trends which are bringing this technology migration for a business transformation in the industry. Just to start with a few examples, what we know, what we've been doing for a few years is the overall electrification, autonomy, which is driving a major transformation in the industry, and technology plays a key role in that, to answer your question.
Great. And having in mind your long trajectory in the automotive industry, you were in the past in with Ford. I would like to know what should an automotive company implement digital and automotive system? What's the way? What's the smartest way to do it?
Yeah, so the digital transformation is one of the key enablers. So in other words, industry has been using a digitalization for a number of years, depending on the company. Now there's how do you leverage that data, and how do you adapt newer technologies like artificial intelligence and generative AI type technology, and combine that with the power of computing on the cloud and bring it all together to do the business transformation. As I just said in the opening, one of the major transformation, industry has been producing cars and trucks for decades. But they've been focused on internal combustion engines. And now going to electrification brings a major transformation both in the product development and in the manufacturing and in the entire supplier ecosystem. So digital transformation technologies become a key enabler to embrace that and deliver business value for the end customer as well as for the OEMs.
Yeah, you talk about data. Data nowadays it's one of our most valuable source, and the way each of the companies manage it, it's what generates value. I would like to know how Siemens generating data and retrieving data to pursue these new developments of the automotive industry with electrification being a part of it.
Yeah, so the Siemens being a technology company, we are into all aspects of product development and manufacturing, and we are bringing together what's called the IT and OT, operational technology. So a lot of data gets generated in the manufacturing facilities, and Siemens is in a unique position to bring the information technology, which is from a product, as well as the operational technologies, and bring those together. Some call it in a closed loop fashion, so you can always get more insights from that data, which is already being generated, and apply those insights to the next generation of the products or in a manufacturing environment to improve the quality of every product coming off the line is better than the one before, because you embrace those changes and you leverage that data and the insights from that data.
What insights have you been able to manage into the transformation of the industry?
Say once again the question.
Yeah, what data and what changes have you been able to detect into the changes of the industry?
So the data, I could use several examples in the product development arena. We leverage all of the data collected, let's say, in an autonomous driving scenario. whatever data is being collected by the sensors, you can migrate that data on the cloud and then leverage that data to design the product site. Same thing on the manufacturing in a plant. We have edge devices, let's say in an assembly plant, in a machine shop. That machine is collecting the data, the parameters or the quality aspects of it, and that data can be exported, and you can do analytics on that data, observe, and then feed it back in the manufacturing to improve the manufacturing quality. Some good examples I would be allowing the predictive maintenance as an example in the manufacturing environment would be some of the use cases. We have several use cases across the industries.
Now, as you mentioned, the vehicle autonomy, it's nowadays what everyone's looking forward. What's going to be, how mobility is going to be, how the vehicle autonomy is gonna be, if it's gonna be the same in developed countries or in underdeveloped countries. Can you explain to me how these sensors and how this data that Siemens has retrieved could help and has helped the research on vehicle autonomy in this way?
Yeah, vehicle autonomy again is obviously the if you talk in terms of the Society of Automotive Engineering definition, there's several levels of vehicle autonomy, starting with the ADAS, automated driving assistance systems, level 2, level 3, migrating to level 4, and ultimately going to fully autonomous in all environmental conditions all over the globe. That's the highest level of self-driving cars, SAE level 5. So you touched on a very good point. Technology is one thing in delivering that autonomy. The policies and every region in the country is making their own decisions how to get safety standards. That's the other aspect of it. And the consumer acceptability, which again will vary from region to region and country to country. All of those things combined together will deliver the overall autonomy vision. We as Siemens are a key technology provider to all over the globe. In the US market, obviously, we're working with the authorities in defining some of those standards, as well as in the European side of the business. There's quite a significant progress in terms of delivering autonomy.
Of course, regarding acceptability that you were talking about, what are the biggest challenges we can face with autonomous vehicles, and how can they be anticipated in this way?
Yeah, so I think the people from a consumer standpoint have to feel safe in driving in those vehicles. That safety remains one of the big challenges. The consumer acceptability from a safety standard standpoint. Since there are no standards as such in defining and accepting those, so you have to be able to prove, or the OEMs, the producers of the vehicles for autonomous level, enough scenarios so that they can show those to the signing off authorities or the certification authorities and come to level of acceptability. As you know, in the US, it is a lot of times done at a state by state level, that you review the level of autonomy and how you prove this to be it is safe, and you work with the authorities to make that a point, and it progresses to those levels.
What data would need to be retrieving to be able to focus on safety, and each individual, like each state or each city or each country, should be retrieving their own data to analyze the security part? What's the data, and what indicators would you be using to take this into Siemens?
Yeah, so the what we have, what's called the scenarios. You generate those scenarios, and you get the physical data collection on those scenarios, and then you start combining the real data with the virtual data, because you can't drive enough or generate enough scenario in a physical driving environment. So we have solutions which allow to create what's the digital twin. So you get the virtual prototype build of the sensors, which are collecting the data, of the vehicle itself, and the environment, and the driving environment. So that's what is called the scenarios. You generate those scenarios, and then you can test those scenarios under all kinds of different conditions, to certify or to justify or to show how the safety standards are being met, or what levels of safety is being delivered using those scenarios.
Of course. And how does the collection of this real world data can contribute in the improvement of virtual simulations? Regarding the sensors that you were talking to me, what else in the real world data can we implement in the virtual simulations in order to improve the development of Siemens platform?
So we do a lot of the different algorithms of the simulation, combining that with the artificial intelligence. There's scenario generations. You can bring in a known scenario, and you can start to bring in what's called the actors, whether it's static or dynamic actors, in there, and started to create other combinations of scenarios and optimize for a given function. So I think this is where it gets a little technical. We could send you the documentation and show how it is being done in the details of all these algorithms, selection, and how the different actors, what I mean by that is, so if you model a vehicle being driven and there's an intersection coming and there's a lighting system, now you can throw in the actors that some pedestrian is driving, but the pedestrian is being blocked by a truck, which is stopped at the red light, as an example. So now that would be an unknown scenario, and we'll be able to generate that within that virtual model, which has been correlated with the physical model first, and I will be able to create what the response of the vehicle would be and how the vehicle will stop in this example. So those are some of the things can be done with the digital tools only, or the simulation tools, and a lot of optimization required playing all these different scenarios.
Of course. And if every single part of the mobility would be autonomous, we wouldn't have these unpredictable scenarios. And this is the complicated part. How do you verify and validate these methods after creating the scenarios in order to have what's possible, what's not, and to give instructions in order for the AVs to take the information and program it?
Now, this is where some of our proprietary technology and intelligence comes into play. There are KPIs like looking at criticality and what's called novelty of those things, and then you can select based on our optimization tools and algorithms like HEADS, which we use in the normal simulations as part of our suite of tools. You combine these things, and that's how you can kind of get to what's called unknown, unsafe scenarios. So the whole idea is this 4-quadrant chart in which you have known scenarios, and then you're introducing those. And goal is to minimize those unknown, unsafe scenarios in this overall development process. So those are the technologies we use in order to get down to minimizing those and bring as many of those scenarios in virtual environment and validate using the same methodologies which we use for the driving the known scenarios.
For sure. And what would be the way of implementing the unknown unsafe scenarios?
The way of implementation is again building on the models, the sensor models, and we obviously have a number of years of experience, and we have these databases of these scenarios. So at the OEM level, adapting those and then going through the development mechanism of running in a virtual setup and then validating the few scenarios which you pick out of those from a critical scenario, even in a physical testing environment.
Of course. And what's the role of AI in this? How can you make it more efficient, these processes with AI? I know that you've been developing some AIs, but how can you improve it and make more efficient?
Yes, AI, I think everyone talks in a general sense, but there's several levels of AI. First, the AI is rule-based, right? The other one is generative AI to create these new things which you didn't think of. It observes the scenarios and creates the next one. So we have AI built in most of our tools at a tool level, whether it's a design tool, simulation tools, we've got AIs building into those. And then we also adapt AI working with a specific scenario. In this driving example, what are we talking about? Scenario generation. There'll be another AI layer on top of it to leverage what we're learning from the previous drive scenario and bring it into the next one. So there's several levels of AI coming into the autonomous vehicle development.
And coming back to the same idea, what's the way of validation with AI? You would have normal situations where the reliability of it's not gonna be entirely. So how can you rely on AI in these processes to complete an autonomous vehicle system?
So you can imagine there's a humongous amount of data gathered and generated. So AI is playing a role in all those steps of data analytics, as well as scenario selections and adapting what is the most probable right thing to pick on and to work on instead of trying to deal with huge amount of data. So in other words, it starts with the very basics of data compression, picking the right data to work on. AI plays an important role in all those steps. And then, of course, in the decision making, when you bring that into the scenario environment we talked about, there's a AI adoption in those processes as well.
Of course. And following this idea, how is this implemented with the digital twin development, and how do you rely on the digital twin?
So digital twin, again, the whole point of digital twin is being able to represent in a virtual or a digital environment what the physical scenario is. And we start the basis of that by doing some data collection on the first vehicle. That's a real vehicle. So now you're able to extract that data and adapt that in your digital models. So that is a good definition of what we call as a functional digital twin. So in other words, you taking the lessons, taking the knowledge from the physical, adapting that in the digital models. So that's the best example of digital twin technology. So of course, digital twin is not only the product development, it builds on throughout the all phases of product. So it walks all the way, let's say, into the manufacturing. Then you have a digital twin in a manufacturing environment. The definition is the same. It's a single digital twin, but now you're bringing in manufacturing knowledge data from the real world and putting it back into the digital models and improving based on the insights you're getting from that physical data. So that's the digital twin plays a role in autonomous vehicle development during the design process into the iterations and setting up the algorithms and tweaking them, so to say, and then all the way into manufacturing, and in fact bringing the feedback from manufacturing back into the product. That all plays a role of the digital twin technology. Sorry, you went on mute.
We lost your audio.
Can you hear me now?
Yes, I can hear you now.
Okay, I'll just edit this. So talking about the digital twin, it's very important to understand how Siemens is doing it. And I would like to ask you to give us an example, a real world example of how Siemens is implementing their digital twins.
So Siemens, as I explained, is implementing digital twin in the product development arena. Example, I'll use autonomous vehicles. So the data being collected from the sensors from a physical vehicle being driven, that data is collected and migrated to the cloud, and then we're bringing that data from cloud to do some analytics and get insights and feeding that data back into the design. So that's a good example of digital twin technology in product development side. We have several examples and use cases, as I touched before, in the manufacturing, since one of the key differentiators of Siemens is bringing not only a design product development, but also bringing in the manufacturing aspects of the business, whether it's the automation or pure smart manufacturing in a factory. So we ability to bring all of that data from the manufacturing environment, whether it's a machine in a machine shop or assembly information or quality information in an assembly plant, bringing in all of that data and feeding it back to the manufacturing.
And how do you find the equilibrium between the real and the digital world?
So I think to me, it's a continuous cycle in terms of you do want to get, when I spent my entire career, what used to be called correlation. Correlation of any kind of simulation or a digital environment. Engineers build confidence when they see that's very well correlated with a physical test. I'm using just a testing development or example. So if you have simulation of a part for durability, let's say how long it's going to live, and then you run a physical test of the same part, it is very important these two come as close as possible so engineers build that confidence based on that. So I think to me, that is the most important digital twin role, is allowing physical and digital to come together so that you can be confident, and that's why you can eliminate some of the physical testing of the prototype build, etc., once you have that confidence.
Of course. And talking about the automotive vehicles and the automation processes, what efforts is Siemens making to expand into the automotive industry and companies on the radar? Which companies are you looking for?
So, of course, once again, the power of digital industries, of which we are a part of, software. The automation is a big business for the automotive world. So, whether it's the factory automation or the motion control or the process automation in a factory, bringing these two worlds together, both from a smart manufacturing into the automation, running the factories and optimizing and making them intelligent factory, that becomes very important. And it is a great merger of these two technologies, automation technologies and the digital technologies, to deliver the overall value for our customers. And of course, we have several examples of that in the industry. Recently, we had this conference, Automate, where a lot of these examples were shared, how our automation in one of the Ford Motor Company plants was leveraged, bringing in the Siemens technologies.
Yeah, of course. What would be a recommendation you would give to an automaker regarding mobility and autonomous mobility?
I think overall for automakers and I would also call the tier suppliers, I call it ecosystem, The change is real, it's coming. Complexity is high as it is in automotive industry. With all the change coming, whether it's electrification or autonomy, the complexity continues to increase. And one of the key enabler to address that complexity and to convert that into a positive business scenario is the digitalization. So digitalization is the key. Getting started, if for those who have not started, but majority of the industry players have already started in those and continue to grow and leveraging AI technologies. AI is an enabler for that digital transformation, adapting those technologies and the computing power from cloud, etc. They all will grow the digital transformation for the industry.
Course. In the past, we see hardware used to be the main part of a car, the main focus of the industry. But nowadays, we start seeing the software taking the biggest role. How do you expect the industry to change in the short and medium term? What new tendencies would be looking to regard, like aside from the autonomous vehicles, what other tendencies would we need to focus on?
I'm glad you brought that up. This is a very important topic. We call it software defined vehicle. So, vehicle typically has been, as you mentioned, hardware driven. Vehicle architecture was starting with the hardware, whether it's front wheel drive, rear wheel drive, what kind of powertrain, etc., to now it is becoming more and more electronics, more and more different electrical architectures, and of course, all that comes electronics with the software, whether it's embedded software on a chip or it's all the application software. So I think that's what is driving the industry because you can offer consumer feature functions through that software. So that is a big shift. So the shift starts from the very early phase that instead of just worrying about vehicle architectures, automakers and suppliers have to think about now electrical architectures. They have to think about electronic architecture, what chips they need to bring in, what SOCs they need to bring in, and also they need to think about the software architecture, what need to provide so that they can optimize from very upfront. Because today, when you offer features through software, you want to make sure you have the enough compute power because the vehicle platform remains the same. Once you sell the vehicle, you can keep it fresh by offering features through the software. So you see the whole paradigm has shifted. This will not, this will drive that if you want a newer feature, newer car, today's environment and mechanical system, you have to take car back to a dealership, either sell that one or get a new one. But now you can see the vehicle life itself is extended and you can leverage some of these new features in the car without changing the real hardware. So it's got a major business transformations of all because of the such a powerful change going on and even in defining the vehicles and these things being driven by software. And you're absolutely right, whether it's autonomy, electrifications are some of the things in between, but the software is driving overall mega change and a bigger change, not only today, but going into the future as well.
Yeah, and you have been immersed in the automotive industry for more than 30 years. I would like to know your personal view of how things have changed, how the industry has changed, how everything you expected maybe 30 years ago weren't weren't the things that are happening now, and how to expect the future.
Yeah, you're absolutely right. There are things, I get amazed every day with technology. That's why I'm doing what I'm doing. The things we dreamt of as engineers just coming out of school 30 years ago, some of those things are possible today. They're becoming a routine job. I remember in the early days of simulations, we used to get stuck in just the computing power. But now there's so many offerings from the cloud providers. Our softwares used to be I call it the early stages, whether it's design or the simulations. These softwares have now built-in AI and self-learning and making it so user-friendly for the customers as well. So the software is evolving, computing technology is evolving, and industry is adapting all those. So industry, from an OEM and supplier perspective, continue to evolve with what consumers need. So they're offering consumers more features, more functions, of course, at a lower cost or a competitive cost. Cost is always a pressure for the industry, and maintaining quality and safety always a priority when it comes to automotive.
Of
So
course.
bringing all these things together, when I said new features are coming, the complexity is increasing, that is huge. Obviously, when we talk about software, what cybersecurity becomes the next challenge, which people didn't have to worry about in the industry as much. Only the computer industry worried about it, or the banking industry about cybersecurity. But now your vehicle itself is carrying enough electronics and software. So those are some of the challenges which are in front of us, and I think we can see ongoing evolution of that in the next few decades, what the consumers will come to expect.
Yeah, and I agree. And what would be those lessons, maybe from the past, that we can learn to implement and adopt in the digitalization of processes and AI?
Yeah. So I think it all comes back to, from a digitalization perspective, nailing down the single source of truth and the trusted traceability of that data is going to be critical, because this is the data you're using for development, and the same data can walk all the way to certification of that information. So even when there's a problem, you can very easily go back and see what caused the problem, and you can fix it quickly. As you know, in the industry, some of the software defined vehicle companies, which have a higher content, even when they have a recall, it's not like the old traditional way. Now you have to spend 1 year or 2 years bringing vehicles back into the dealership and fixing. They can fix them with the software update over the air. So you see how the industry is evolving, is already evolved to some extent, and now everyone else is adapting and how it is evolving. So all those are changes coming with all the technology we are bringing into the vehicles.
Of course, everything's changing. Processes are faster now. And I would like to touch base on your personal experience in this industry. If you would share with us one significant experience that you have had in your life that you're proud of, or that you were able to implement something that has changed your trajectory or the industry's trajectory.
I think I would say my personal experience, and I feel good about, is not a single experience, it was a journey. So I went through an experience since I worked at Ford as a safety chief engineer in delivering the highest safety standard for the largest volume product Ford makes, which is the F-150. So we were proud to deliver the 5-star rating, which is the highest level of safety rating on F-150. As a safety chief engineer, that was my role in there. Now, what's important in there is the major transformation Ford Motor Company went through was the first in the industry. They went from a steel vehicle to an aluminum body. So that was the major shift in the vehicle design development process. So for me, the journey was starting a decade before that experience of safety in the materials engineering, going through the specification development, aluminum development, and bringing that change in the manufacturing, and bringing that ultimately delivering to a customer benefit of delivering safety. I think that's what I feel the most proud about at a personal level.
Congratulations for being able to achieve this in your life and also to change the way safety is projected in the industry. And just for us to finish these wonderful conversations filled with a lot of wisdom, lessons, and knowledge, what would be a message you would like to give to the new generations entering to the industry, entering to technology regarding artificial intelligence, autonomous mobility? I would like to hear your opinion on this and your message.
I would say to the next generation coming, it's a great time to be in technology. It's a great time to be in engineering. Stay focused on something what you have a passion for and deliver that. And along the way, always stretch yourself, push yourself to learning something above and beyond what your day job might be. And you will see the scope is unlimited. I think 20 years from now, someone entering in the industry and in the development, things will definitely look way different than we are imagining today. I wish I knew when I started, but I know looking back only 30 years, I had no idea of how 30 years later things are going to be. So, only thing is the attitude, positive attitude, continuous learning, and delivering at the same time will take us way beyond in technologies we can even imagine today.
Thank you for your message. I think there's optimism, but Nand, should we be trusting autonomous mobility?
Yes, I think that is the goal. That's why the SA has established these levels and standards. I think some people want to just imagine the highest level of autonomy, which is SA level 5, right away. Others have taken approach of migrating those level 2 to level 3 to a level 4 and then building into a self-driving cars. I am in that camp of adapting over a period of time, getting the results, and then making it, because safety is absolutely critical, and then going to the next level of autonomy following that path. And I think the second important piece is it's not just technology, customer acceptability, and our policymakers bringing it all, their processes in place together. That is the practical way of moving forward, because these things do take time and you have to take the step functions. But we will get there.
Man, thank you so much for this talk. Thank you so much for being able to transmit everything that's going on in Siemens DIS. And thank you so much for being part of Automotive Talks and Neuron Business Media. See you in the next episode. Thank you.